much is 41?
It's 29 at my house.
Okay.
Let's
Let's go ahead and get started. I cannot believe today is already Tuesday, March 14th, right?
Friday.
What's that?
It's
Pie Day.
Kroger selling pie for
3.14.
$3.14.
Ah, there you go.
Get your pie today.
It is Pie Day. That should be. I heard that on the news this morning and actually forgot it.
Yes, us too.
What's that?
We celebrated it in high school.
In math
Like,
class,
everyone brought
A
everything.
pie. And all you did was eat pie all day. It was
You know, I find that interesting. We never got to do that when I was in.
We should do
Of course,
that now.
my math teacher was like a 6'6" basketball coach, and he was pretty scary actually. But he was really a good teacher. But we didn't do anything. We didn't do anything like that. He just
forced
laid it out, and we were supposed to learn it.
I was like a 5'2" old lady.
All day too.
All right, well, let's go ahead and talk about where we're at, where we're headed. So we're going to do the exam review today. I actually will be here all day today till I finish up whatever grading I need to, which I anticipate being 6 or 7 o'clock tonight. So if you have anything that you need, you have until then to kind of touch bases with me. Tomorrow I'll be traveling, so I will probably check email towards the end of the day tomorrow, but I won't be around the office. And then Thursday you're going to come in, and Dr. Super is going to come in, and she's going to proctor the exam for me. If you would, when you come in, and I've told her, just go ahead and plan on sitting one to a desk, right, and make sure you bring your calculator. I will try to get her a few extra, but I'm not sure if I'm going to catch up with her today or not. So make sure that you bring your calculator so you're ready to go with that. Other than that, when we come back from spring break, you need to be finishing your Part C or working on your Part C of your project that week. So make sure that you're actively doing that. What I've noticed is that the on-campus projects, you guys tend to do a pretty good job of catching up with me when you have questions. The online students maybe not quite as much. Some of them do better than others. So make sure for the online students specifically, make sure that you're focused on Part C going into that week, and that you get with me if you have questions early in the week so that you have time to make adjustments and revisions as you go. So that should be your focus when you get back as Part C of the project. And then we're going to come back then on April 4th, and I'm going to take a quick overview of Chapters 6 and 7, which you won't have a test over. So that should be a pretty relaxed day for you all to come in. It's information that's in the text that I think is important to kind of get the overview from how this text looks at both inventory in terms of analysis and then the safety inventory. But it isn't something that I want to spend a bunch of time going over problems with you. I think we've done some of it in 343, and so, but I want to add just a little bit of the twist of what this text, how it kind of presents it to frame it up. Because some of you may have a need to kind of use some of the information from that in your analysis, and some of you won't. And so, again, I want to do that. Then we're going to spend some time on Chapter 8 and Chapter 9 to kind of finish out the semester. So again, we're kind of coming, the end's coming quickly is what it looks to me like. So, and what you should, I hope, feel is that we pressed pretty hard the first part of the semester, and things should, and I even hesitate to say it because I don't want you to lighten up too much because you still have your project to get done. But you should feel it kind of lighten up a little bit here as we finish up into the end of the semester. So we'll have our last exam before dead week, and then we'll just do presentations in class in the finals week. Okay, so that's kind of how the rest of the semester is going to shake out. I did go ahead and put together some practice problems to go. Did you have a question, Abby?
The 28th and the 30th are both work days?
Yes. So, and if...
Is that spring break?
What's that?
Is that the week after spring break?
That's the week after spring break. Yep. So, spring break here, project here. Okay? All right. What's that?
I just got my dates confused.
Okay. You're like, is she telling us we're working on a project over spring break? Because
No, it's just not.
yeah, my son came home. He's got some math homework that's due like the Wednesday or Thursday when he gets back, and he was telling my husband, he's like, I can't believe they assigned me homework over spring break. And I'm like, well, they didn't really, because it's not due when you get back, right? It's due at the normal time of the week. And he's like, right, but I'm like, look.
Dr. North has something due over spring break.
On that Thursday.
On Thursday.
Of
Oh,
spring break.
sorry.
And the Tuesday after.
Yeah. Both.
Okay, so I'll visit with him about maybe not doing that.
Actually, he moved the one that's due over spring break back. Like, it was supposed to be due like this Tuesday, so.
Gotcha.
So honestly, I'm not that.
Okay, so there's the rest of the story.
Yeah.
Right? Now it comes out. All right, so I'm not talking to him about that. It seems to me
done
like he was
yet,
trying to
so.
be helpful. Okay, so I did put together some practice problems for us to kind of work through here today. I will post the blanks, so if you want to run through them again, and I'll post whatever solutions I write up today. I'll make a digital copy of them and post it as well. But I'm going to go ahead and use the camera here. I just wish I could figure out how to make it just a little bit brighter. Seems like it should be. But it, as bright as I can get it. Okay. So, just to give you an overview of the exam, it is 150 points. There are 34 multiple choice questions. They're worth 2 points apiece, so that's going to be 68 points out of the 150. Okay. Quizlet is your friend, right? Use that to prepare for the multiple choice part of it. And I'll try to remember, I'll create an exam module to post this and the link to Quizlet. And so that should kind of help you with the multiple choice part of it. And then there are roughly 82 points from problems. 36 of those come from Chapter 4 and 46 of those come from Chapter 5. It's just because Chapter 5 has a little bit more complexity to it, so there's a few more points associated with that aspect of it. All right? So let's walk through the types of problems that you are likely to see on the exam. Okay. Okay, so the first problem that we're going to look at is from Chapter 4, right? And that's linear process flow. We have linear process flow and nonlinear process flow from Chapter 4. And so a manufacturing process for a portion of the assembly line consists of the following steps performed in the following sequence with the associated flow times and activity times. Right? Sometimes it's just easier for me to just draw a quick diagram. So I have basically 3 steps, right? And so I'm going to go 1, 2, and 3. And so my flow time is 5 minutes here, 4 minutes here, 2 minutes here. So the average flow time of the process, 5, 4, and 2, so 6 and 5 is 11. So it's 11 minutes. Make sure you use units of measure. Okay. What is the theoretical flow time of the process? Well, that's only going to be our activity time, right? And our activity time for each step is 2, 1, and 3. So 3 and 3 is 6 minutes. And so
Is step 3 0.3 minutes
what's that?
for activity time?
Oh, no, I'm sorry. That was supposed to be just 3 minutes.
Okay.
Okay. So that was a typo. So 6 minutes, and then the flow time of the flow time efficiency is where you take the theoretical flow time and divide it by the average flow time. So 6 divided by 11 is 54.55%. Okay. And I just added a note on here that I want you to understand how to do flow time with rework and flow time with visits. So I'm just going to use this as an example. So when I do that, we're just going to be looking at the flow time, not the activity time. And so I'm going to say, well, if I have rework, let's say that at the tensioner, 10% of it has to go back through the process. So the tensioner is step 2, right? And so for rework, I'm going to go 5 plus 4 times 110%, right, plus 2 to get my revised flow time. So 4 times 110% is 4.4. So 5 plus 4.4 plus 2 gives me 11.4. Okay. So the most common mistake on the homework where people saw that and said, well, then I'm going to take the entire process flow time times 110%. And it's only this particular step that you have to do the rework on. Okay? And in terms of visits, right, let's say that only 50% of the parts have to go through the sash frame press. So we're going to say 50% on step 3. And so then that becomes the 5 plus 4, right, plus 2 times 0.50. Because only half of them actually are going through that process.
Does it say skip on?
What's that?
Does it say 50% on
step 3?
Oh, step 3.
Mm-hmm. And so 5 plus 4 plus 1 then gives me a revised flow time of 10 minutes. And those two are actually written as individual problems, so there won't be any question about, well, am I doing E on what I did in D, or, they're just separate little problems. But I wanted to walk through an example of those. Okay? And then in the next one, this is a nonlinear process, right? We have 2 legs going into 1 leg, and so it's nonlinear because every unit doesn't go through every single activity step. Okay, so to understand the flow time of the process, I have to look at the flow time of each path. And so if I look at path 1 as being the top path, it's 0.3 plus 4 is 4.3, plus 8.3 is 12.6, plus 10 is 22.6, plus 0.5 is 23.1. Everybody on board with that?
Mm-hmm.
And if I look at the bottom of it, right, the path 2, it's 2 plus 2 is 4, plus 10 is 14, plus 0.5 is 14.5. So 2 plus 2 plus 10 plus 0.5. So what's the flow time of my process? 23.1 or 14.5?
23.1.
23.1. It is the longer path, right? Because I can't finish until that's done. So that's that's kind of the key thing to remember when you're looking at a flow time on a nonlinear process. It is the longer path of the 2 paths. Okay? And so then the question is, well, what is the capacity of the process per hour? Okay? Do you remember, what do we look at when we're thinking about the capacity of the process per hour? What are we looking for in the process?
The bottleneck.
The bottleneck, right? And so the bottleneck would be which step takes the longest, right? So I look in constructing the cabinet, it takes 10 hours, right? So the capacity of the process is 1 cabinet every 10 hours. Or 0.1 cabinet every hour. Sorry, I wrote that and it was too low. So then the question comes up, well, what if we say we want to add another person on the bending the steel work, right, to reduce the cycle time at this workstation to 2 hours? So then what happens to the, I don't really want to say theoretical there, I just want to say flow time. So what happens to the flow time of the process if we change the time at bending steel from 4 to 2?
Reduces it by 2 hours?
It reduces it by 2 hours. What happens if I take the assemble rollers from 2 hours to 1 hour? What happens to the flow time? Nothing, right? So the key there is to remember the only time the flow time is actually affected is when it's on the critical path. Okay? And then I'm just going to encourage you to go back, so that's what the note is about, to review the discussion boards with linear and nonlinear process flow times. I am going to ask you to draw a simple process flow, so you had that in one of your discussion board examples. So just be prepared to draw a pretty simple process. Okay? All right. So this next problem is coming from Chapter 5, right? And we're going to talk about Shelby Manufacturing specializes in 2 types of production. The typical work involved in each product type is quite predictable and repetitive. The time requirements or unit loads for preparing each type of product are shown in the table below. The contribution for product A is $2,000 and the contribution margin for product B is $1,800. Also listed are the number of resources of each type and the number of hours each day the resource is available. I want to kind of, again, throw in an example, and you'll have it in 2 problem types where we're going to do a very simple effective capacity, and then we'll move on to the blended effective capacity, okay? So this problem just jumps right into the blended, but what I'm going to do is, let's assume that we're asked to determine the effective capacity of product A. Right? So I'm going to have the assembler. I'm going to have shipping. I'm going to have the manager. Okay, and I'm going to have the unit load for product A in hours per unit. And that's 10, 2, and 2. Okay, so the first thing I do is I need to get the effective capacity for A. And I'm going to do that, which you all should know, by taking the inverse, right? So 1 over 10, 1 over 2, and 1 over 2 gives me 0.1, 0.5, and 0.5. So that's the effective capacity of A in hours per unit. And then to get my effective capacity of the resource pool, right, I need to know the number of each resource available. Resource spells correctly, we hope. And it's 8, 6, and 4. So the effective capacity of the resource pool for A is 8 times 0.1, which would be 0.8. 8. And that's going to be, again, in hours per unit. Sorry. Effective capacity is in units per hour. I didn't translate that right.
Can you move your paper over?
Better. And so 0.5 times 6 should be 3. And 0.5 times 4 should be 2. And just out of practice, what's the bottleneck resource there? What's the bottleneck resource?
Assembler.
Assembler, right? It's going to be the lowest units per hour in terms of effective capacity. So what I've done is I've given you kind of okay, let's do a very simple effective capacity problem, right? And then we move into the more, okay, now we have two products, now what are we going to do? So on the exam, you're going to see one that's going to be, here's one product, give me the effective capacity of the resource pool, okay? And then, okay, now let's go ahead and move on to a more complicated version with the same concept.
Can you leave it up there for just one more second?
Sure.
Okay.
Did you say okay? Okay. All right. So then we move on to the problem, and it says, so after reading all this and understanding we've got product A, product B, number of each resource available, and the hours that they are available per day. And so again, in the very simple version, I don't include, I think I just tell you the number of resources, and I don't include the hours available per day. And then when we get into the more complicated one, then I add in the variable of hours available per day as well. So in this example then, what we're going to do is, what is the effective monthly capacity of the process at the current product mix? Okay. Well, what we should know about that is the very first place I need to start is I need to get the artificial unit load, right? Everybody agree with that? Right? So if I'm going to do that, I'm going to go ahead and set up my table here for the assembler, right? The shipping person, and the manager. Okay? And so I want my artificial unit load. And it's going to be in hours per unit. And I think this example is a 50-50 example. So because I have 150 orders, 75 of each type, your problem won't be 50-50. So you will need to make sure that you use the percentages, don't just average. So we're going to walk through it using those percentages. And so if I need the artificial unit load for the assembler, I'm going to take 10 hours per unit times 50% plus 6 hours per unit times 50%, right? And that's going to give me an artificial unit load of 8 hours per unit for the assembler. For shipping, I'm going to take 2 hours per unit for product A times 50% plus 6 hours per unit times 50% for product B, and the average of that is going to be, or the equation comes out to 4 hours per unit for shipping.
So why are you taking it by 50%?
Because the split of the orders, if you look in for the month of March 2014, 150 orders were received, 75 of each type were generated.
Oh, okay.
That tells me that I've got a 50-50 split. Okay? All right. And so then in terms of the manager then has 2 hours for product A times 50% plus 2 hours for product B times 50%. And that comes out to be 2 hours per unit. Okay? So then this becomes, now we have our artificial unit load, and then it kind of reverts back to what we do in a basic effective capacity, where we take the inverse of that to get to the effective capacity of one resource. So then it's 1 over 8 is equal to 0.125, and that's going to be units per hour, right, because it's the inverse. 1 over 4 is going to equal 0.25, and 1 over 2 is going to equal 0.5. Okay? And so the question, if we go back, says, what is the effective monthly capacity? Okay? So to get to monthly capacity, I need to know the number of resources in each pool, and I have that in the table, which is 8, 6, and 4. And I need to know how many hours per day are they available? And I know that that's 6, 8, and 4. And I need to know how many days in a month. And we're going to assume 20 because it tells us that in the problem. So to get to the effective capacity of the resource pool, I'm going to take 0.125 times 8 times 6 times 20. And that's going to equal 120 units per month. For shipping, it's going to be 0.25 times 6 times 8 times 20. And that's going to equal 240. And for the manager, it's going to equal 0.5 times 4 resources times 4 hours per day times 20 days in the month equals 160 units per month is what the effective capacity of that resource pool is. Okay? So the question actually asks us, what is the effective capacity of the process? But we have to work through this in order to get there, right? So what's the effective capacity of the process? 120 units per month, right? So something I saw when I was grading, I saw some people tried to add the 3 of them together, right? Now we're looking at each resource and identifying where our bottleneck resource is, okay? And so our bottleneck resource is at the assembler, and so they can only do 120 units per month. So I'm going to come up here and I'm going to answer that question, 120 units per month, okay? And so then the next question, can the company process all 150 orders in the month of March? Or clearly if our process capacity is 120, the answer to that is no. Given the current product mix, what's the bottleneck? Well, we've identified it as the assembler because it is the lowest effective capacity of the resource pool, okay? And so then the question is, if the firm wishes to process all 150 orders, how many employees of each type are needed? Okay, I think people struggled on that one a little bit more in the homework than maybe what I thought they would. And so don't overthink it, right? So the question is asking, how many do we need in order to do, how many of each resource do we need? Well, we know that we want to do 150. We want each resource to do 150. And we know how many units per hour one resource can do because we've calculated it right here. So if I need to know how many, the first thing I have to do is say, well, how many total hours of that resource do I need? So I'm going to take my 150 orders times the effective capacity of what one resource can do, right? To understand how many total hours I need, okay? So if I'm going to do that, I'm going to go ahead and go to a blank sheet. You can probably work on the back side of one of your, of that, or pull out another sheet. But so for 4D, to look at the assembler first, how many assemblers do we need? Right? We have 150 orders that we want to do. Okay? And we know that it takes an assembler 8 hours on each unit. So I'm actually going back to the unit load there to get the total hours. I think I said that I was going to use effective capacity. We're going to use the unit load. So 150 orders at 8 hours for each order, right, says that I need 1,200 hours of assembly time. Okay? All right, so if I need 1,200 hours of assembly time, how much does one assembler, how many hours?
Wasn't the assembler 6 hours?
So we're looking at the artificial unit load, right? Excuse me. We're
okay.
So it's 8 hours. Okay. All right. So one assembler. how many hours does an assembler work in a month?
6 times 20.
Okay, and so we know that an assembler is available 6 hours per day times 20 days in a month. Then that's 120 hours per month. So if I know that an assembler is available 120 hours per month, and I need 1,200 hours, right? How many assemblers do I need? I take the total hours needed and divide it by the total hours one resource is available. Right? And so that's going to be 1,200 hours divided by 120 hours per month. And that's going to tell us that we need 10. I'm going to drop down, so we need 10 assemblers. And that's probably my my unit of measure here should be it's 120 hours per assembler in a month. And then that might make more sense in terms of unit of measure for folks. So then I need 10 assemblers. Okay. So I'm going to walk through that same process for the shipping. So for shipping, how many hours do I need? I have 150 orders from my artificial unit load, 4 hours per order. So 150 times 4 tells me that I need 600 hours. One shipping person. Hours per month. It says that they're available for 8 hours per day times 20 days in a month. Leaves me with 160 hours available. And so the shipping needs 600 hours divided by their available for 160 hours one person is. And so 600 divided by 160 says I need 3.75 shipping personnel. So we got shipping, assembler, and then of course last but not least I need to do that for the manager as well too. So on the manager, it's 150 orders at 2 hours per order. It says they need 300 total hours. The manager is available 4 hours per day times 20 days in a month. Which is going to give us 80 hours per month for the manager. Okay, and so then it becomes number of managers needed is my total hours that I need of 300 divided by how many one manager is available, which should tell us that we need, I think, 3.75 managers as well. So you just have to, don't overthink it. I think some people, the first thing you want to do is figure out how many hours you need in order to do however many units you're being asked to look at. And in this problem, right, it is progressive. So you've done an artificial unit load, so now you're using the artificial unit load to determine how many people you need to do the assignment. Okay, so that was D. And then E says, well, what type of product is most profitable? Okay, I've combined this in this problem. On the exam, I've put it in a separate problem. So you're going to finish to the point, I think, where you get the number of people, and then you're going to go on to the next problem. And part of that is because I'm trying to keep maybe some confusion out of it for you, because when we go to look at profitability, are we going to look at combined unit load, or are we going to look at individual unit load? Individual, right? And so, but for the practice problem, we're just going to use the same set of data, okay? But because we have contribution margin, right, but we don't have contribution margin per unit of time, and that's what we have to figure out in order to address which product is actually more profitable. And to get to contribution margin per unit of time, we have to get to what the capacity of the process is for each product, right? And in order to do that, we basically do our basic effective capacity for each product and then identify the capacity from that. So let's go ahead and do that. Okay. And so I'm going to do product A. Assembler, the shipping, and the manager, and we have the unit load for A, which was 10, 2, and 2 respectively. So then I'm going to do the effective capacity, which is 1 over 10 or 0.1, 1 over 2 or 0.5, and 1 over 2 or 0.5, okay, times the number of hours that resource is available. Oh, excuse me, times the number of resources available times the number of hours per day that they are available. Okay, kind of messy headings. Sorry about that. All right, and so then it's given to us in our table. So we have 8, 6, and 4 in terms of number of resources available. They are available for 6, 8, and 4 in terms of hours per day, right? And so to get the effective capacity of the resource pool per day, I'm going to take my effective capacity times the number of resources available times the number of days, number of hours per day that they are available. So 0.1 times 8 times 6 is 4.8, right? And again, that's a measure of units per hour. My shipping is going to be 0.5 times 6 times 8, which is going to be 24 units per hour. And my manager is going to be 0.5 times 4 times 4, which is going to be 8 units per hour. So what's the effective capacity of the process for product A?
4.8.
4.8, right? 4.8 units per hour because that's the lowest. And we said our contribution margin for A was $2,000 per unit. So the contribution, or the contribution per unit of time for A is going to be $9,600 per day because we took the 4.8 times the 2,000, right? That gives us our contribution margin per unit of time. Now we need to repeat that for product B. so we can determine which one is the more profitable product. So we're going to do product B, and we're going to have assembler, shipping, manager, unit load, for product B is given to us as 6, 6, and 2 respectively. So therefore my effective capacity is going to be 1 over 6, 1 over 6, and 1 over 2. 1 over 6 is 0.167. Of course, 1 over 2 is 0.5. And again, we still have 8 resources available for assemblers, 6 for shipping, and 4 for managers, right? They have the same hours per day of 6, 8, and 4. And so in order to get the effective capacity of the resource pool, we're going to multiply 0.167 times 8 times 6, which equals 8.016. 0.167 times 6 times 8 is equal to 8.016, right? And for the managers, 0.5 times 4 times 4, which gives us 8. Okay, so it's really close, but which one is our bottleneck?
The manager.
Manager, right? And so if we recall, our contribution margin for product B is $1,800 per unit. So I'm going to take 8 times 18, and that's going to give me 14,400, which is my contribution margin per day, my contribution margin per unit of time. And so product B is actually more profitable, right? Because I'm showing 9,600 versus 14,400 is how much I can produce in a day. The expectation is that you're going to do that work and show me that work. If you don't do that, right, you can't just pick one and put product A and not show me any work and think you're going to get credit for it. You need to show me you understand how to do that process. Okay? All right. And then let's see, what is it? At the current product mix, what is the value of hiring an extra assembler? Okay? And so if we were going to do that, we're going to find our artificial contribution margin, which in this case is 2,000 times 50% plus 1,800 times 50%, which gives us $1,900 for artificial contribution margin. So if we were to hire an extra assembler, one approach, there's probably more than one way to get there. One approach is to just look and say, well, how much does one assembler, if that's our bottleneck when we have the combined product, you remember, so we have to kind of go back to our first look and say that the assembler, when we have our product mix, is our bottleneck. And so basically what we're saying, well, if I added one more assembler, how many more could I do, right? And so in order to get that, you could say, well, we know that our effective capacity of a resource unit at the bottleneck, which equals the assembler, it's going to be 0.125 units per hour, and they're available for 6 hours per day, $20 days per month. Which means that they could produce 15 units per month. And so the value of adding one is going to be equal to how many units can they produce. So they can produce 15 units per month, and each unit is worth $1,900 in terms of contribution margin. So then I'm going to go 15 times 1,900 tells us that that would be worth $28,500. Probably be worth it to hire an extra assembler, right? So that's the long drawn out version of that problem. It'll be broken into two separate ones on the exam, but the work that you need to be able to do is consistent there with what we just demonstrated. And then we go to what I think of as a much easier one. Right? And we go to theoretical capacity problem. And again, if you show me your work and you make a math error, I can give you partial credit. If you don't show me your work and just give me a solution, it's either all or nothing. So I encourage you to, even on the simple ones, just show me your work, okay? Because it doesn't take that much. So in this case, to get to theoretical capacity of the resource pool, right, you should remember that theoretical capacity is equal to your effective capacity divided by 1 minus the contribution waste factor, right? And so, divided by 1 minus, you can just say waste factor, right? So it's going to be, in this case, it's going to equal 5.5 divided by 1 minus 0.2, or divided by 0.8, which is going to be 6.875 contracts per day. For the tax lawyer, your theoretical capacity of the resource pool is going to be 10 divided by 1 minus 0.3, which is going to be 14.3 contracts per day. And last but not least, your senior partner is going to be 7 divided by 1 minus 0.35, which is going to be 10.8 contracts per day. All right? And so again, there's no formula sheet. I'm not going to provide any formulas, so make sure you're familiar enough with them to come in and remember how to work that. Okay? And then the very last note you'll see says, students should also review throughput improvement mapping. You had a discussion board question on that, basically where we looked at what happens when you have this relationship between throughput and capacity and theoretical capacity. What I'm going to do is I'm going to give you an example where throughput is almost the same as capacity. And then what do you do? I'm going to give you an example where capacity is almost the same as theoretical capacity. And then what do you do? I'm going to give you an example where throughput is much less than capacity. And then what do you do? Right? And so we had a discussion board question on that. And so I just want you to go back and review that and make sure you're comfortable with where you need to focus your improvement efforts or what you would do in each of those situations. So that one's just kind of a go out and memorize and make sure you're comfortable with that. Okay? All right. Any questions? Do you have any questions for me?
Yeah, will you go back to the first one? How do you do E?
So E is like a visit. So what E is saying is, like, think of it like maybe you have an inspection process when you first receive something in, and you only inspect 20% of the product that goes through your process. So you take whatever flow time is associated with that step and just multiply it by 20%.
Okay.
Rework is kind of the opposite of that, and it's saying that you're having units that are repeating the process. And so then it's like if it's a 10% repeat, then it's multiplied the flow time for that activity is multiplied by 110%, right? Because you're doing more through the step versus less. So you basically have to decide, is the description saying I'm repeating, like flow units are repeating through that step, so it's going to be more than 100%, or not all flow units are going through it, so then you're just multiplying it by the actual percentage of visits. Okay? So that's the difference between D and E. Okay? Good question. Any other questions? No? All right. Like I said, I'll go ahead and post the YouTube of this recording as well as the blank and the what I wrote up here in class. And so you all can have that for review as well. And Jan, Dr. Super, should be here on Thursday. And I always tell the story. I was part of the interviews. I was part of the selection team when she was hired. Have I told you this? And everything was the super interview and the super lunch and the super. I told her, there's no way she wasn't going to get hired, right? It was the super. Everything was the super, right? So, other than that, I hope you all have a really great spring break.